Consider this. Is it possible that we're looking for life on Mars in all the wrong places? When we think about the most likely places in our solar system to find life besides Earth, Mars naturally comes to mind. In its first billion years, Mars had many similarities to early Earth, and it's entirely possible that life could have emerged on its surface before the planet underwent changes that made it less hospitable. That's why NASA's rovers, like Perseverance, are exploring places like Jezero Crater, hoping to find traces of ancient life in dried-up deltas. But as I've delved deeper into this topic, I've realized we might be searching in the wrong spots. There's another area on Mars that might be even more promising for finding life. And what's even more exciting, it could be life that still exists. Today we'll dive into the possibility of a subsurface biosphere on Mars and discuss where I believe we are most likely to find signs of life on the planet. Before we discuss the possibility of life emerging, it's worth revisiting how life begins. Keep in mind, we'll be speculating a bit since even here on Earth, many aspects of the origin of life remain unknown. In a recent video, I talked about how life might have originated and emphasized that there are still many debates on this subject. It's also important to note that we don't have definitive proof that life existed or exists on Mars. But there are some intriguing clues. For example, NASA's Curiosity rover detected methane in the Martian atmosphere that appears only at night and disappears during the day. On Earth, methane is mostly produced by living organisms, so this could be a hint at the possible existence of life on Mars. However, this is not conclusive evidence, as methane can also be produced through non-organic processes, which I discuss in another video about life on other planets. So why do scientists think that Mars could have been, or still be, home to life? It all starts with what Mars was like in its first billion years after it formed. According to our best theories about how life originated on Earth, there are a few key elements. Water is the first and foremost, as all known life requires it. But also important are the mechanisms to create complex chemical structures, the building blocks of life that could have led to the formation of primitive cells. Something like a deep-sea hydrothermal vent or volcanic hot spring could have helped in this, releasing streams of minerals and chemicals that, under certain conditions, could have transformed into the simplest protocells. Finally, for this process to work, there needs to be some kind of selective pressure to choose some chemical structures over others. It's similar to evolution. The process wouldn't work without some selective pressure guiding it. For animals, for example, that pressure could be a lack of food, forcing those who are best at finding it to survive. But what could drive the survival of chemical structures? Imagine a cyclical environment that is sometimes wet and sometimes dry, creating conditions that test endurance. Structures that break down during these stress tests are filtered out, while those that survive continue to develop. It's a kind of evolution, but for rocks. On Earth, there's evidence that life originated within the first billion years after the planet formed, which in cosmic terms is incredibly fast. Interestingly, Mars also had these key factors during its first billion years, and perhaps even more. It had a thick atmosphere and a magnetic field that protected nascent life from harmful solar radiation, allowing bodies of water to form without the risk of rapid evaporation. Mars had volcanic activity that provided energy from the planet's core and essential chemical building blocks. Sunlight also added energy to the mix. If these factors made Earth suitable for the origin of life, it's possible that Mars had the same potential. However, there's a time limit. After 1-2 billion years, the water on Mars dried up. The planet cooled, and the mechanism powering its magnetic field ceased. A few 100 million years later, the atmosphere was stripped away, and all the liquid water evaporated, leaving only frozen deposits at the poles. So, if life existed on Mars, it would have had to emerge in those first 1-2 billion years after the planet formed. NASA operates under the assumption that this is possible, which is why it sends rovers and landers to explore craters like Jezero in search of ancient signs of life. As of April 2024, Perseverance has collected 21 rock samples, drilling several centimeters beneath the Martian surface. Jezero Crater was once home to a large body of water and a delta. If living organisms once inhabited these waters, their remains might have settled at the bottom of the delta and been buried in sediment. There's even a possibility that they're still preserved in that sediment today. Researchers from the journal Astrobiology have discovered that certain types of bacteria on Earth, even when fully desiccated, frozen, and exposed to intense radiation, could theoretically survive for hundreds of millions of years, simply waiting for life-supporting conditions to return. This finding explains why scientists are so cautious about cross-contamination when exploring other worlds. But if life isn't found in Jezero Crater, there's another possibility. It could exist in the underground lakes of Mars. You might say, "Alex, didn't you mention that all the lakes on Mars have dried up?" And that's true, but not entirely. While liquid water likely no longer exists on the Martian surface, there is a place where water still persists, even in liquid form, deep beneath the polar ice caps. In 2018, scientists announced the discovery of a large lake trapped beneath a thick layer of ice. By 2020, the existence of 3 more such lakes had been confirmed. This is intriguing because it resembles an ecosystem on Earth, Lake Vostok, which is also a lake located 4 kilometers beneath the southern polar ice cap. Lake Vostok was discovered in the late 1990s, and it has been found to contain bacteria, possibly even fish. Some DNA traces have been brought to the surface. Lake Vostok is a fascinating ecosystem that has been isolated for 15 to 25 million years. Unfortunately, the likelihood that Martian lakes are another Lake Vostok, teeming with ancient life, is quite low. Due to significantly lower temperatures on Mars, it's believed that the water in its polar lakes is extremely salty. This doesn't support the development of most forms of life. Moreover, it's possible that these lakes on Mars don't exist at all. A recent study in the journal Science Advances suggested alternative explanations for why radar images might show a lake, proposing that closely spaced layers of dust could create the same effect, essentially a type of optical illusion. Expanding our view on the possibility of life on Mars, let's take a closer look at another key hypothesis: the existence of liquid water in underground reservoirs, potentially connected to geothermal activity. Scientists have long speculated that hidden bodies of water could exist beneath Mars's surface, and recent data only reinforce this possibility. Specifically, linear streaks on the Martian surface that appear and disappear periodically might be the result of liquid water emerging from underground reservoirs. If these hypotheses are correct, these reservoirs could be some of the most promising places to search for life. Imagine these reservoirs as analogs to Earth's underground lakes, sustained not only by water but also by heat from residual geothermal activity. In such conditions, even without sunlight, microorganisms could survive by using chemical reactions to obtain energy. This is similar to what we observe on Earth in extreme environments, such as hydrothermal vents at the ocean floor or subglacial lakes in Antarctica. Water hidden deep beneath Mars' surface could be a refuge for ancient microorganisms that have adapted to the planet's harsh conditions and may still be living today. It's also worth noting that the Martian landscape shows signs of intense volcanic activity in the past. If thermal springs still exist beneath the surface, they could provide a crucial energy source for subsurface ecosystems. On Earth, volcanic vents are hotspots for biological life even in the most extreme conditions, where organisms use chemicals released during volcanic processes to sustain their life functions. In the context of Mars, this means that the possibility of hotspots beneath the surface where microorganisms could survive due to heat and chemical elements is quite real. These isolated ecosystems could have existed for billions of years, even after the planet's surface became inhospitable to life. This scenario opens new perspectives for future Mars research, suggesting that life on the planet may not only have survived, but might also still be actively functioning in certain regions. These considerations lead to an important conclusion. To increase the chances of success in the search for life on Mars, future missions should focus on studying subsurface structures, especially in areas showing signs of past or present volcanic activity. For example, regions around large volcanoes, such as Olympus Mons, or areas with recent cracks in the planet's crust, might be particularly promising for finding signs of subsurface life. At the same time, we must remember that exploring the deep structures of Mars requires the use of advanced technologies that are currently in development. While on Earth we can use deep-sea drilling rigs or explore deep mines, on Mars we are limited by the capabilities of landers like InSight, which was only able to drill a few centimeters. To reach potential underground lakes or volcanic sources, we will need much more powerful tools. However, it's worth noting that despite all the challenges, searching for life in the deep layers of Mars is one of the most promising strategies. If we manage to confirm the existence of such underground ecosystems, it could completely change our understanding of life as a phenomenon. Life on Mars may not only have originated in the past, but also survived in conditions that seem extreme to us. This opens the door to new hypotheses about the existence of life elsewhere in the solar system and even beyond. So when we talk about searching for life on Mars, it's important to look not just at its surface, but also to delve into the planet's interior. It's there, beneath the protection of the Martian crust, that traces of life may be hiding, life that has gone through billions of years of changes and adaptations. And although we are still far from a definitive answer to the question of life on Mars, each new study brings us closer to this understanding. Perhaps beneath Mars's surface, we will find the key to solving one of the greatest mysteries of the cosmos. If this is what's happening on Mars, it's entirely possible that the lakes we talk about aren't actually there. So, Jezero Crater appears to be a more promising location for the search. But even it has its downsides. While Jezero Crater may have been habitable, it's not the best place for life to have originated. There are no deep thermal springs or volcanic hot springs that could serve as a cradle for life, as in the Columbia Hills region. Thus, the question arises, could life have originated in another part of Mars and spread quickly enough to reach craters like Jezero before the planet turned into a barren world? It's possible, but it's also possible that this didn't happen. As the planet began to cool and the water evaporated, any bodies of water would have become increasingly salty, as the concentration of salts increased while the volume of water decreased. Excessive salt levels are harmful to most forms of life, and studies suggest that this could have been a huge obstacle for the survival of underdeveloped protocells. Such cells simply might not have had the mechanisms to survive in such conditions. Even more advanced Earth life would have struggled, especially given the diminishing atmosphere and harsh radiation levels. Therefore, it's better to search for life where it might have originated, rather than in places where it could have spread. Thus, volcanic springs like those in Columbia Hills seem more suitable for searching for traces of early life than Jezero Crater. If life on Mars never progressed beyond the primordial soup, these initial bodies of water remain the most logical places to search. But when it comes to where life on Mars might exist now, volcanic springs have another important advantage. They could be gateways to underground biomes. Why leave the water when you can follow the nutrients directly to their source? On Earth, life exists not only on the surface. There is an entire world known as the deep biosphere, located kilometers beneath our feet. Life there has learned to survive without sunlight, without air, in environments with high temperature and pressure. And astonishingly, it thrives. In 2018, a group of over 1,000 scientists from the Deep Carbon Observatory published a study estimating that the mass of all living organisms beneath the Earth's surface is nearly 400 times greater than the mass of all humans on the planet combined. The deep biosphere spans nearly 2.3 billion cubic kilometers, almost twice the volume of all the oceans. It contains 70% of all Earth's bacteria and archaea species, as well as viruses and tiny worms. It is generally believed that the biodiversity of the deep biosphere is at least as great, if not greater, than that on the surface. To date, there are no established limits on how deep or in what hot conditions life can survive, as records are continually being broken. For example, the current record for the highest temperature at which a living organism has been found is 121 degrees, hot enough to boil water, and the record depth is 10.5 kilometers below sea level. Food in deep rocks is scarce, so the metabolic processes of living organisms in the deep biosphere occur 10,000 to 1 million times slower than on the surface. If life exists on Mars, it would be developing very slowly, meaning these organisms might live almost indefinitely. We don't yet know for sure. Some bacteria found in various parts of the world show that despite traveling through solid rock, bacteria somehow manage to move. It's only in the last decade that we've begun to grasp the scale of Earth's deep biosphere. This information is incredibly useful when discussing potential life on Mars. Deep beneath the surface of Mars, life would be well protected from the destruction occurring on the surface. Life capable of surviving in thermal springs would have had the opportunity to penetrate into warm, nutrient-rich underground layers through cracks. They would only need to descend. Given the slow metabolism of such organisms, it's quite possible that they are still living there. Perhaps a thriving ecosystem exists beneath Mars' surface today. Determining this for certain will be very challenging. Even on Earth, we struggle to explore the deep biosphere using deep-sea drilling technology or very deep mines. On Mars, landers like InSight have managed to drill only 2-3 centimeters. But in my opinion, this is exactly where we should look for life on Mars today. Of course, it's important to remember that there are many ifs. If life ever originated on Mars, if it managed to escape from hot springs, where it likely first appeared, if it evolved and adapted like on Earth, only then could it still exist there. But it's captivating to imagine that while Mars's surface seems dry and barren, beneath its soil there could be a thriving ecosystem that is still alive today. Perhaps this is why methane has been detected in Mars' atmosphere by the Curiosity rover. Of course, life could have spread to bodies of water like Jezero Crater. but I think that if it still lives, it's deeper. When it comes to searching for life on Mars, I am convinced that we have only just begun this journey.